sebab saya pengguna. Dia lebih kepada macam orang review kereta, dia tak buat kereta pun tapi dia boleh guna lah, tu je. So sebagai dalam industri saya, kita guna pneumatic untuk design our machine untuk buat produk benda lain lah. Macam company saya, kita buat DC motor, direct current motor, dan mostly kita guna pneumatic compared to hydraulic lah. Dan the reason is easy to maintain compared to hydraulic, dan equipment dia lebih kecil compare dengan hydraulic, dan dia lebih centralized. Kita guna satu kompresor daripada depan untuk satu plant, cukup. So kalau kita guna hydraulic mungkin kena set up individual lah, by machine. Okay, introduction saya tu je. Kalau boleh kita buat, boleh interrupt lah anytime. So saya open. Okay. Pengenalan sudah. Untuk kita straight kepada penggunaan tu lah, boleh?
Boleh.
Okay. Tak, saya cuba share video. Okay. Macam mana nak sharing? Sorry. Okay. Boleh nampak?
Ya.
Okay, ini contoh pneumatic system yang kita guna as a transferring product. Kita pick and place lah. So dalam sistem ni kita cuma ada yang mostly kita guna adalah linear cylinder, movement forward backward, dan kita ada turning dan chuck. So tiga ni mainly used in kita punya factory lah. So macam konsep ni just transfer from one conveyor to another conveyor. Simple. So walaupun kompleks mana pun, yang ni basic lah, selalunya kita akan guna. Dan kita ada belting conveyor dan so on. Okay, satu lagi. Okay. Sini yang dah motor kita transfer daripada turntable. Dan sini kita panggil turning cylinder. Yang ni kita boleh control 180 forward backward. Dan kita ada chuck yang move up down dan climb. So macam ni lah. So boleh nampak dekat mana pneumatic lah. Okay. So pneumatic ni kita control by PLC. So PLC akan generate the supply to the valve, dan valve akan control the flow of compressed air. So ini antara PLC yang kami guna. Saya sharekan. Okay, sini mini-bag kebanyakan kita guna Panasonic PLC. Dan kalau tengok lampu-lampu yang klinik ya I/O communication lah. Kita bila dia on dia akan supply the 24 volt to the valve to operate the system. Dan simple lah pneumatic ni. So the valve, flow valve, okay, ni kita punya valve. Lihat. So nampak lampu yang menyala-nyala tu 24 volt dah masuk dan dia akan open the valve flow in dan flow out. So sini kita ada satu kita panggil booster untuk control the pressure in our machine sebab mungkin daripada kompresor kita jauh, lebih kurang mungkin dalam 100 meter daripada mesin ni atau mungkin 200 meter dekat kita punya sistem. So mungkin akan dapat less pressure drop. So this booster akan regenerate the pressure untuk maintain our requirement pressure for our machine. And we use about 5 MPa. Okay. So far ada apa pertanyaan tak? Clear?
If you unplug the PLC, does it disrupt the whole system?
Sorry?
If you unplug the PLC, does it disrupt the whole system?
If you answer, sorry.
Unplug.
Unplug, yeah, sure. If we unplug, because it's like a brain of our machine. So without a brain, you can operate the leg or hand and so on. Yeah, this pneumatic is controlled by electricity also. So if no electricity, then you cannot produce the operation.
So the system in Mini B, dia memang fully electropneumatic or ada yang pneumatic saja?
Kita memang kebanyakan fully pneumatic lah.
Memang control by PLC lah.
Yeah.
So, ada tak yang bahagian yang memang macam production line ke yang just operate based on pneumatic only?
Macam mana tu?
So dia boleh, kalau dia electropneumatic, dia control by PLC kan?
Ya.
So kalau ada tak yang just control just by valve movement tanpa elektrik?
Tak ada. Semuanya electropneumatic. Bahagian saya machine is automated.
Ya. Okay, selalunya satu sistem tu dia ada berapa banyak yang actuators? Cylinder ke ataupun rotary actuators? Selalunya ada berapa banyak yang attach dengan satu PLC?
Sangat fleksibel, depend pada how big the machine we want to develop. Dan so far paling banyak PLC can control up to 256 IO. So this PLC we can add on IO, so boleh constrain lah.
So the circuit tu designed by locally or
Ya, kita ada engineer electrical dan mechanical ya.
so nak control 256 tu, so memang a lot lah kan.
So as a programmer, saya
Yeah.
punya main is a programmer, so we have to program the ladder.
Okay, so any other question so far dari pelajar? So I think it's a good opportunity for you to ask. So tolong tanya. Kalau ada soalan tu, I think we have a good. Yes.
Hello.
Okay. Yes. Yes.
Hello, ya.
Nak tanya,
Boleh.
kalau pekerja baru,
Okay.
macam kalau ada pekerja baru masuk, ada tak orang yang akan terangkan pasal alat-alat yang kita guna ni? Penawarti ni.
Okay. Ada. Kita akan buat satu training dulu lah. Kita orang panggil apa, orientasi ya, dalam 2 hari untuk safety dan sistem. Dan kebanyakan bila dah masuk, kita akan attach ke senior punya engineer or technician. Dan lebih kepada hands on on job training lah. Sambil kerja terus belajar dan less class hanya teaching. So direct attach to production line dan follow senior dan belajar, dan bila kita confident dan kita akan let go untuk try buat sendiri lah. For the maintenance and design. Firstly, kita akan letak mungkin dalam production untuk biasakan dulu how we operate. Okay.
Okay, terima kasih.
Okay.
Okay. So ada soalan lain so far?
I just want to ask, what does the orientation would consist? Would it be like macam a whole day to like teach them how to use the machines, ataupun just macam a short introduction, so that the new worker knows how the machine functions? How is the orientation like?
Orientation will be conduct like a class for the 2 days before we attach to the production. The first is mainly about the safety lah. Before you go to the site, then safety is the first to develop. Then for the technical part, mostly will be on the site. And we understand student maybe no experience, so that's why we attach to the senior. So to understand the job scope and so on. So don't worry, our senior will be guide. And does that answer your question?
It's practically macam dia briefing kejap dan terus attach ke production.
Yeah. Bila attach, senang to understand the actual working environment.
Yes. Okay. Any other question?
Can I answer this question?
Yeah.
So for my head, the one PLC can control 250cc into output. So how do you maintain the connection of plug the PLC, and how if anything happen at to the system, how do you readjust or maintain it back to the normalized it?
Okay. There, for the whole machine, there is a lot of sensor to detect the movement of every cylinder, either go forward, backward, up, down, turn. So the sensor will determine the position of every cylinder. That's the important thing. From the signal, in sensor signal, then PLC will control the movement. Is it the exact position we want it to move or not? So in case we want to cylinder to move forward, then there is a sensor at the forward to turn on if this successfully go to forward direction. So in case there is a delay, timer, maybe the cylinder is blocked by something, so the sensor will be not turn on. So the PLC will use this situation to understand and will be alarm the machine. And we have to determine how dangerous it can be. So there is a tier 1, 2, 3. How, for example, in machine we have an interlock. We call it interlock to avoid the inappropriate movement. So, for example, the movement should be at the up only can go forward. So if not fully up, halfway, then we move forward, maybe can hit another cylinder. So this will interlock system will be used to control our pneumatic. Is it clear?
Yes, thank you.
Okay.
Okay, any other question?
Okay, so if I want to share more, okay.
So I think you boleh continue.
Okay.
Nanti kita open balik.
So previous is just a small machine. So next I will go to a more auto machine. Okay, this is example. Okay, you can see. This is how a frame is transferred. We are using pallet. Then there is a transfer post by post. So if we, on the safety matter, this chuck must be open. Every chuck there is sensor to make sure everything is open, then only this thing can come down to pick the product. So in case the chuck is not open, then will be hit the product. And same to movement, forward, backward. There ada sensor to make sure this cylinder up down. Can see this red color meaning the position is up, and kalau the turun bawah nampak bawah ni blinking merah. So we make sure this both cylinder is up, only we can move forward. So many sensor involved to make sure the movement is safety. Okay. Next, another pick and place. I'll show example. So here we have sensor for detect product, and we pick up, then move to our desired location, then we place it. So there is a auto feeder to supply this one, inductor, and the front is our capacitor terminal. Okay. Sini ada turning. So first, sensor will determine the orientation of inductor. So in case this need to turn, then this cylinder, PLC will instruct this cylinder to turn. In some case, there is no need to turn because the orientation is already in a good position. And from here, we can see mostly pick and place product. Okay. Next, this one will more bigger machine we have. We call this assembly machine. Okay. Here we have a turntable, where this one controlled by motor. And every station will place the product. And this is the start. And then next process, then there is a press machine. The press, mostly we use a servo motor. The old one maybe have a hydraulic one because we need more power compared to pneumatic, less pressure. So, but if using the hydraulic one, this unit will be more bigger because we need a tank and motor pump and so on. So nowadays we mostly convert the hydraulic into the servo motor. So this is transfer. Okay, next we have a dispenser here to dispense a glue. Also controlled by pneumatic. We call it dispenser. Okay. Itu saja. Sorry. Dan untuk cylinder movement ada okay, sini kita akan assemble the commutator. Okay, fokus dekat sini this cylinder. The cylinder actually using a linear up and down, but we using a gearing to make it turn. So the actual cylinder is up down, then convert to using a mechanical to make it turn up and down. So in terms of design, we can use multiple way. There is no one method. So the engineer will have to be creative, how to minimize the space and how to get the work movement done. Okay. Okay, that's okay. So far the purpose soalan tak? Oh, kita ada test. Sorry. Ada soalan dari Fakru Azim. Dia tanya, in your opinion, is it easy to convert ladder diagram to actual circuit implementation? Actual circuit meaning using a pneumatic alone or so ladder diagram to convert actual pneumatic system alone is difficult because it involve a lot of controller valve punya ya. Using the micro electro pneumatic is more easy because the ladder save a lot of hassle and and the first is space. Using the pneumatic alone will be a lot of device to be construct compared to combine with the PLC ladder diagram. Same in electronic. At first we are using on just relay. So if every output need to construct by relay, then will be for one or two movement, then it's okay. For me, if more than 3 is not worth. The best is using a controller because this controller we can first also safety. We can define the machine condition and to avoid accident. Then also we can easy to indicate a machine keeper what's the problem for through the touch panel HMI. Okay.
Biasanya ambil masa berapa lama untuk convert tu?
Convert apa tu?
Untuk dari diagram untuk jadikan pneumatik tu lah. Ambil masa berapa lama?
Ladder diagram ke pneumatic macam mana tu?
I think maybe in terms of
Macam
nak design lah electro-pneumatic system tu.
Oh, the whole system ah. Okay, macam tadi yang satu mesin design can be 1 month. And mostly we have already have our basic construction. So we just pick whatever we want to use and combine it. Then it can reduce up to 2 weeks. So
Yeah,
from
yeah.
2 weeks,
1 month tu berapa banyak I/O?
1 month can be more than 30 IO, 30. So if using only 1 or 2 IO can be done in 1 day. So depend how big the machine we want. and is it already available or not? Because kebanyakan kita dah ada dah structure awal, just pick and place lah. Unless totally new concept, then 1 month is a standard lah. Then from ordering also took about 2 weeks, depend on available or the availability of the component. So from the after all the product arrived, then the small machine can be assembled within 3 days, but the big one can be up to 2 weeks for the mechanical. After the all part attached, pneumatic usually take 3 days to tubing, and also for the wiring also mostly 3 days. This one will be moved together, pneumatic, tubing and wiring for one machine. Then as a programmer, programmer is quite tough. So if the system already same with previous, then it can be 1 day, because just transfer the old program and troubleshoot. So if a new one, maybe 2 weeks. So from the start project until the test run complete, until we deliver to the production, can take 3 months. For one project. But as here, at the same time, we are not only focused on one project, so there is multiple project will be carried out at the same time. So time management is very crucial. So you have to work as a team. Okay.
We have a few questions here. Tentang chat box.
Chat box.
What language is used to program the VLC?
We use in Minibear, we use a ladder diagram. Because PLC there's a multiple, there is a script, there is a block diagram, there is I understand many more. But in Minibear alone, we mostly use a ladder diagram. Okay, next is, it is safe to play with pneumatic equipment at home. Pneumatic is safe compared to others, but you need a compressor to make it work. Then it's a hazard free compared to hydraulic, and also fire, can save from fire because it's just a air. The only issue it will be heating. That's all. Next is what inspection always done to electropneumatic system before starting the machine? So before we operate the machine, we must ensure the system is functioning. Firstly, we must check the air pressure incoming. So if uncontrolled, if too high, then we can break down our system. And if the pressure is too low, then we cannot achieve our production speed. And also it can be dangerous also, because the movement will be not fully operate. Then it can be halfway movement. So the sensor will be trigger the alarm. Okay. Kos untuk penyelenggaraan mesin-mesin tu mahal ke? Okay, untuk pneumatic system, untuk maintenance tak semahal hidrolik, because untuk operate to generate the compressed air is itu yang mahal. Sebab the compressor dari starting dia kita dah loss lah, 30% tu confirm loss. So yang mahal dekat generate the compressed air. Untuk maintenance the cylinder, valve and so on, just hope no accident. Because if accident, the cylinder will be bengkok, patah. Itu mahal. Satu cylinder 300-400 lah. So lagi besar mungkin 2000 satu cylinder boleh jadi. Break itu bukan maintenance, itu breakdown lah. Kalau maintenance is tak mahal.
Selalunya gunakan actuator jenama apa? Panasonic juga.
Actuator sini Japan company, so they choose Misumi. Misumi for the most reliable lah in our experience. But in case we want to save the budget, there is AirTag. AirTag, the price can be 1/3 compared to SMC. But there is a issue on the reliable. So for the simple area, then we will select attack. In case there is a more crucial area, then we using a SMC. So we have to mix and balance the budget also.
I think semua dia ikut budget lah kan.
Yeah,
So we go back to budget.
SMC is the best lah.
Macam dekat Unimark kami gunakan Omron. So,
Okay.
is it like easier to convert to Panasonic type of PLC?
This one PLC kah?
Yeah. So
Okay, PLC, Omron, Panasonic is about the same because they're both from Japan based. Compared to European based PLC, like Siemens, and there's be a little bit constraint to convert. So Omron, Panasonic is about same lah.
then the orientation of the ladder diagram pun lain kan?
Yeah.
Ada yang flat, ada yang menegak.
Itu we in term to the layout lah, to understand, to familiarity. The difference may be on the how the display the timer and counter. As for the switch on, normally open, normally off, normally on, off, and this output our general output will be same, except if we are using more we call high level language. There's about data orientation, so the data processing can be very different if we want to play with the bit and value.
So how about the expandability of the system? Boleh sambung dengan IoT So I think now dia move
Okay.
pada IR 4.0 kan.
Okay, IoT Industry 4.0. Okay, this is the interesting part. As you can see, the previous machine, actually, the machine is located at Sungai Petani. And I currently working at Putrajaya and house. So from here, I can remote the machine, enter the PLC alone, just using a remote system. So this, and in terms of IoT, some device we need to change to get the value. Mostly machine using a IO on-off signal. So we cannot get the, for example, the movement, how many distance it actually moves. So there is a equipment to convert. So if management decide to implement the IoT, for example, this previous machine we show is we can say achieve the IoT level, because from there we able to track every data and we keep in our server. So IoT is about to get data and process, store and process how we want to. Sometimes orang understand IoT just ambil data. Kita ambil. We don't know how to utilize the data. Also a issue. So when management decide, say we want to operate, install the IoT system, first we have to understand what we want to keep. And after we keep it, how we want to use the data. So that's important. And for the Panasonic, the new PLC FP7, there's a internet base, so we can say it's achieve our IoT standard.
Ada satu lagi soalan dari ni chat box. So mesin tu kalau nak baiki kilang akan bayar ataupun customer akan bayar?
Okay. Of course, kilang akan tanggung. Okay. Sebab ini mesin kilang, so kita is just a employee. So there is a maintenance cost, and there is a standard part, storeroom of the standard part. So everything breakdown must be repaired within 1 hour. 1 hour is actually very long. As in a product manufacturing, if 1 hour we can produce about 5,000 pieces motor, then 1 hour loss is very high. So company must design the system to avoid the breakdown. That's why we have a preventive maintenance, and also we have predictive maintenance. And in case maintenance has already been done, but there is a breakdown, so we have to fix it. The best is less than 5 minutes. If more than 10 minutes, the manager has already come down to us investigate why. So 1 hour machine not operate is a big loss to a company. So as a employee, we have to control the budget also. But in case happen, then we have to fix no matter how much the cost compared to the loss of our production. Okay, how much money is needed to operate the pneumatic machine for a day? Okay. Okay. How to operate? So in terms of operation, I can focus on to generate the compressed air alone. This depends on how big our plant. this is very subjective. So the bigger the plan will be more expensive running costs. In mini bed alone, the cost to compress air can be more than 100k for a month. But we have a lot of machines, so this justify the usage. So this is where we have to control the leakage, because the pneumatic is we have centralized, so leakage is very affect the cost, because at the first starting to generate is already expensive. Then if a leak, a small leak, it's like we throw away the money. So make sure there is a no leak in the system. Okay, next is kalau mesin tu rosak sebab kesalahan kita, kita kena bayar balik. Okay. So far dekat minivan tak ada isu lah benda tu. Kita tak boleh nak blame the employee. The worker have the reason why what is happen. So in standpoint of manager, kalau nak blame employee tak jalan operation. So the cost will be bear by everyone. So it's maybe if we can see it is on purpose, then it will be issue a warning letter. But if there's accident is accident, not on purpose. So first time maybe we can say it's a mistake. Second time then we will issue a warning letter. But jangan risau sangat. Okay, next is how much precision at least is needed when assembling a pneumatic circuit. Okay, in my experience, pneumatic is not about the position to control. If we need a position when we will move to servo or stepping motor, this is more accurate movement. Okay, to assemble the pneumatic circuit. In case we mistake on system, the cost will be effect on the mechanical part. So that's why we have a two color tubing for in and out to avoid the mistake. So just make sure you plug in the tubing correctly. And for wiring, just the connector already fixed, so there will be no forward backward. So only one way to plug the connector. And on the IO side, if you mistake the wire, the pneumatic stay safe, not burn. It's just cannot energize the magnetic, so the valve will not operate. So no issue for assembly process. It's not if small mistake can break the machine. It's no, unless you totally mess up the whole system. It's safe enough to assemble. For the beginner also, it's safe. Okay, next ada.
Okay, maybe boleh check up sikit pasal the piping yang digunakan.
Okay, piping. Saya ambil video tadi ada. Saya run video satu ni, kita tengok cara piping dia. Okay, nampak every cylinder there's a two color of pipe. The blue and yellow. So this is one way to avoid mistake. So in this case, the yellow is initial. The blue is initial, and the yellow one is for the on valve. After valve on, then the flow will go to the yellow one. So if the valve magnetic is off, then the airflow will through the blue side, blue pipe. Okay. Nampak? Same here. So this cylinder valve turn on, then the airflow will go to the yellow to move the stroke out. And valve off, then airflow will go to the blue tubing to retract back the cylinder. Nampak? Boleh faham? Boleh? Ada soalan?
Dalam chatbox ada satu lagi soalan.
Okay, if we want to do maintenance on the section, do we have to stop everything else? Okay. This is tricky because production they will try to run, and on the maintenance side we try to stop for our safety. So on the maintenance side we have to schedule it properly dengan production member. Some maintenance need to stop, some maintenance can be done online. So depend on what type of maintenance we want to do. So the best is operate online, but there is a safety concern. So only few experienced people can do like this. But as a beginner, my advice, stop the machine first. Okay, ada satu lagi. Pada pendapat Encik, kebiasaan pekerja perform dalam bidang ini macam mana? Apa kualiti manager tengok pada pekerja? Okay. Kita tengok level kat sini. Kalau kata technician, first how they identify the problem. So the best pekerja, they can identify as soon as possible, then also do the fix. And yang perform tu is straight away to the source, the root cause of the problem. If others, maybe they can take a long route to identify until the root cause. So mungkin silinder macam mana? Untuk evaluate pekerja ni payah agak ni. So the best, how well the pekerja is knowledgeable on the machine, how they can fix, and how they understand the machine very well. And for attitude is also, and the main is attitude also. If you are very good at technical but in attitude also no good, that's also an issue for management. So the well balance is both. You have to strong in technical and attitude. Okay. Ada lagi?
Okay, so ada soalan lagi? Maybe buat masa ni tak ada lagi.
Okay, ada. Okay, sini contoh dispenser. Saya belum tunjuk lagi kan. Di sini kita apply dispenser, apply grease, control by dispenser. So except a movement, we also control to dispense a semi-solid. And also we can, sometimes we can apply the oil using a pneumatic system. So macam-macam boleh buat. And next, maybe there is a vacuum. Vacuum. There's vacuum. Okay. Example, the application for the vacuum. Okay. So kita boleh guna compressor untuk vacuum, blow, cooling part compared to the cylinder alone lah. Okay, ada apa-apa soalan lagi?
Okay, so any question? So ada soalan?
Okay. Next is more to working. Kita share sikit. Untuk pekerja ni sebenarnya kita ada different area lah. Macam bahagian saya untuk design machine is under design team. Then there is a under maintenance team. So everyone have a different KPI to achieve. As for the maintenance, first is to reduce the breakdown, to do the maintenance on the machine properly. And as for design team, we have to design the machine a constraint budget first. Then we have to design the concept to achieve what we want to do to our product more efficiently. And the best design will go to how less we apply the movement. So if too many steps, then also affect the cycle time of the machine. To produce one product will take longer time. So the best design, it can minimize the total step of movement. For example, if we want to move from A to B, how fast we can move it. For example, if up and down, maybe, for example, from this video, we try to reduce the step. Okay, so this video can show two different method. Okay. Okay, first from the pallet, from the front, to transfer from station A to station B, for example, only just one move in, slide forward, then step two. Then actually within two steps, the product already arrived from A to B. This is the best because only two steps required to transfer. But in this case, this one may be not the best one because it need to move down, one, chuck, close, two, move up, back, three, forward, four, down, five, open chuck, six. So 6 steps required. 1, 2, 3, 4, 5, 6. Then need to up to more safety, 7. So there is a different method to move the product alone. But this is necessary due to how to apply the chip, because this is need to piece by piece to get into the charger magnetizing. So as a designer, the best design will be less movement is the best. So you need to be more creative. Maybe some other company there is more different method which is more faster than this one. So design theory need to be more creative actually. Okay, ada soalan ke? Chatbot Sir Fakru Azim. How many pneumatic components are able to work on a newcomer? Macam mana ni? Boleh huraikan sikit?
I think maybe kalau kita baru join as a freshie,
Okay.
beberapa banyak yang selalunya dia dapat experience lah pneumatic component yang sistem yang dia boleh develop. Maybe as a novice.
Macam mana?
So maybe kalau dia baru join, this the
Okay.
first job,
Ya,
so dia tak ada experience.
ya.
So selalunya berapa banyak komponen yang they can play around ataupun boleh
Okay. For the newcomers, in minibar, firstly we attach to the production line, so there is not to play around. Actually, you are direct just to the machine. And so the not one machine, there is a production line. So one production line can be about 20 to 30 machine. So if you in charge for one, then all the machine equipment at this line is belong to you. So you have to take care of the equipment. So in case you want to learn, we have at our development area. So this one not fully attached to the production, then but you have to do at your own time out there from working time. So if you are willing to spend time, maybe if you shift morning shift, then at the midnight you can go to play around at the development center. I just say on about mini bear alone. For the company, I'm not sure.
Ni macam kalau mini bay, dia ada plan lain tak? Kat Malaysia.
Malaysia mini bear kita ada 3.
Okay.
Main is Sungai Petani, dan dekat Batu Pahat Johor satu, dan satu lagi kita baru dapat dekat Klang.
So ada tak macam chance the machine is produced dekat SP tapi transfer to Batu Pahat ke or other plants?
This 3 plant, the product alone is different. For Sungai Petani, we produce a DC motor. For Batu Pahat Johor, we produce a adapter charger. So this one already totally different product. And for the Klang one, we produce a car key, also different. So unless you are in charge on machine, there is a chance. For example, myself is in charge on Sungai Petani, but I station at Klang. So on the machinist, there is a same we can apply the technical any plan. So there's a chance to shift. Unless you are under product design, there's a totally different. You have to start up from the bottom back. And also we have a chance to go to Japan. And for example, myself already go to Cambodia, Philippines, China. So if you are able to get into the MNC, multinational company, there's a chance to travel. Except this pandemic area lah. Before this, I always go to overseas because the technology is about the same. So if your technical skill is good enough, Malaysia is the best team for in our organization, because Malaysian well versed in English compared to Japan, unless the new one. So Japan will use a Malaysian team first, go to Philippines or Cambodia, and also we have a station member at Europe and USA. So the Japan is a lead, but they use a Malaysian team as a main. There's an advantage for Malaysia. Okay. And also Unimed also one of the advantage actually. Industry very looking at a Unimed student. So the expectation is quite high compared to others. Because the senior already put a lot of hard work to make sure the Unimed student is the best. Okay.
I think we have one more question here in the chat box.
Okay, next is Putra Nadi. What will happen to the unqualified product during production? Okay, this is we call NG, not good product. Depend on how bad is the product. If it can be reused, then will be reused after few repairing, debugging. If the defect is too high, then we scrap the product. So the NG will be, we have many reason why it's happened. First is manpower and also machine, and also sometimes it's a product itself, material. So if the damage is there, we have 3 rank: A rank, B rank, C rank. So A rank totally cannot use, must be scrapped immediately, and must be passed to the supervisor to avoid its flow out to customer. Okay, next is pneumatic machine can be used for smoothies. What's okay? Smoothies apa ni, buat air tu kah?
So maybe he's asking about other use of application of pneumatic. Adakah dalam mesin smoothies tu digunakan pneumatic juga?
Macam mana tak faham, sorry.
Okay, maybe the student is asking about application, other application as well. Yang kita bagi tahu ni on the industrial side.
Okay.
Macam mesin untuk buat smoothies tu.
Okay, smoothies tu. Smoothies tu, in case there is a plant, then it will be possible lah. Kalau stand alone kedai mungkin not viable lah. Because to generate compressed air alone is, you can see, not available, not good enough lah for small and shop. Maybe the motorized will be the best solution. Okay. Boleh buat tapi on the big scale. So the small scale is not, the running cost is not good enough. Better use a standalone system, motorized one. But the running cost, if motorized, for example, one machine may be higher than pneumatic system. But if you are running a lot of machine, then pneumatic system can be justify the compressed air. Current to generate the compressed air is expensive. Okay. Adik ada soalan tak? Mana adik? Tak ada.
Okay, so any other question? So, kalau ada soalan tu, tolong tanya. I think so far tak ada kot.
Okay. So first, okay, ni kita just sharing lah. Kebanyakan still guna pneumatic as a main, but slowly we are moving to robot. So, for example, here we are using a SCADA robot. Because the flexibility of the movement, you can see it can go to the tight space and moving more. For example, this we have a 4 axis, so SCADA robot is more viable nowadays. Not say pneumatic is no good, but this can be used if moving in 3D dimension. So if we want to more than 3Ds, for example 6 axis, then the robot will take a place.
But how about the cost?
The cost is very expensive. One robot can go up to berapa yang ni, this one maybe 60,000 for one robot. But we pay for the position and flexibility.
Tapi programming dia different, right? So
depends. Some robot already have built-in controller. We can just set the position, then PLC just call the data by I/O, and also sometimes can use a serial communication or Ethernet port. We have multiple way to communicate to the robot. But yeah, the cost constraint is very high at the initial cost. Anyhow, to justify the air compressor cost, running cost also, it can be a balance for the long run.
So how about the maintenance for this?
As for maintenance, I think we need just a greasing. Same to the pneumatic for greasing. So maintenance is same except the breakdown cost. So this one already run about 2 years so far, so good. Mostly business our investment will go up to 5 years. If more than 5 years, then it's good enough.
I think we have another question, like a chat box. What kind of philosophy is needed in engineering?
Philosophy is needed. Macam mana tu? As an engineer, the main philosophy is to contribute. If you are engineer, the main is we contribute to the society. It's not money oriented. Okay. The most satisfying when we can develop and it can be fully utilized to our community. This is the satisfaction on myself also. And when we can maintain the product company, so we can sustain our production, so we can give a salary to our operator also is a good. So mostly we must think how we can contribute, what we can improve our society. This is what happened to engineering. We solve the problem and always think the new solution. We cannot stick to one solution. from time to time, the world is moving very quick. Technology also very quick. So if we not make, then others will make it. So there's no one man standing. I can say, oh, I'm alone, can do this. No, this is about community. You have to contribute. Then on the money side, they say come alone. If you contribute enough, then the money will come. That's it. So the solution is not always. For example, one day we fit moving here direction. In the next 3 days, one idea will come. Why not we move it like this? So always changing in manufacturing. In my experience, already 8 years, then there is no one solution from beginning until here, until today. Always changing. Then as engineer, we have to explore whatever opportunity have, or maybe we have to match the others technology. We must utilize it. So and if you have your new concept, then you have to share to others. Then we will develop our world, not only our factory. For example, Malaysia alone have a fuel sharing to other Japan, to Cambodia. Then so two competitors, so we have to fight. If next is, what is your hardest project and you can talk about it? Hardest project. On my experience alone. My hardest project during the pandemic. Because we want to develop a new production line. This machine actually collaboration from Malaysia and China. Then during March 2020, we do a lockdown, and China team already arrived and they have to go back. Soon we announced to do a lockdown. Then myself is only engineer available on programming for machine programming at Malaysia, and maintain our mechanical and electrical team also have to do ourselves. Compare when we our plan, we have about 20 manpower combined Malaysian and China, but then happen about 8 member. So this a very tough situation last time. Even though we can communicate to using our communication, but on mechanical side we have to do a hands job, that stuff. And also because we need to fit a deadline to deliver to our customer on and at the end of year. And also consider the customer is a continental, which is a European base. Their standard is very high compared to Malaysia and Japan, very high. So you have to meet their standard. And yeah, this is my experience. Anyway, don't give up. Finally, we still able to achieve it. We can go through. Just don't give up. Just put a lot more effort. If previously we can use 7 to 8 hours, then you have to contribute 12 hours a day. Okay. Ada lagi?
Okay, so any other question dari students?
Hydraulic side, I actually not well prepared. Very sorry, but I just sharing the press machine. Okay, here there is a press machine. This is how usually we apply the hydraulic system. So because hydraulic is more precise, this one a gearing insert. We insert the gear. So if you are using a pneumatic system, the precision is not good enough compared to the hydraulic. Okay. And also the load applied for hydraulic is more higher than pneumatic. So if we want to use the heavy load, then we will decide for hydraulic system. One more. Oh, the second one also a press machine, same. So when we decide to use a heavy load, then we go to the hydraulic system. The rest we go to the pneumatic and also motorized. Okay. And that's what. What was your diet as an engineer? Okay. Diet, tak ada, makan je apa pun. Okay. Ada soalan lain?
And so far tak ada kot. I think we already covered all the questions by me.
Okay. On my sharing, so that's all. Nothing more. So just waiting for Q&A, if anything.
So, okay, so ada soalan ke? I think we will open our official Q&A. Walaupun in between kita ada banyak soalan. Encik Ahmad Mahathir pun dah answer dah all the questions along the way. I think so far it's a very engaging session because banyak soalan. Ada yang technical, ada yang tentang diet, ada banyak. So
Boleh, semua soalan boleh.
Preparation as an engineer, I think because their journey pun as an engineer pun still along the way. So they finish their diploma, nanti sambung degree. I think then I think mostly will go to the industry. So I think they are mentally preparing untuk jadi seorang engineer kan. So I think it's a very good sharing lah dari Encik Ahmad Mahathir. Okay, he's alumni Unimap. I think Unimap product, so you can relate more with the Unimap student. So I think please use this Q&A session. So, kalau ada soalan tu, please tanya so that you can get the full use of the talk lah. Okay, untuk dapatkan semua input. Okay, so ada soalan lain? Okay, dari pelajar. Okay, any final few questions?
Okay.
Okay, boleh on mic dan tanya ataupun boleh tulis dekat chat box. Okay. Ada tak soalan?
Dan come on, Unimac. Unimac sekarang saya tak pasti macam mana. Cuma dulu zaman saya lah, just sharing lah. Memang pergi merata. Duduk kelas kat bawah, kat Kanga, Kuala Pole. So this one also to develop mentally to go to our working area. To prepare the mental lah. Memang nampak macam pelik. Tapi Unimac buat macam tu bila masuk industri pun sama. Hari ni ada kat Kemboja, esok ada kat China. Many time. So there's a life. So sekarang tak pasti macam mana pula. Macam dah ada kampus baru kan.
Dia more centralized dah sekarang.
Sekarang dah central.
Reduce cost.
Kalau macam dulu lagi best lah.
Boleh.
Nampak macam teruk tapi sangat membantu lah to develop student. Okay. Dia punya survival skill untuk Unimac student memang tinggi lah dulu.
How about career opportunity dekat Minibi? So,
Career opportunity lah.
yeah.
So far, every year we are recruiting. And we not stop because our production also expanding. And we try our best to bring the product from overseas to run at Malaysia. So we have to convince our HQ at Japan. So that's our job to convince them. So when they agree to decide run at the Malaysia, then we will recruit a new member to in charge the production. And so far, we are still expanding our production because Japan also look at a Malaysian as a technical person, which is a good opportunity to Malaysian. So this opportunity we cannot lose it. So we have to maintain the momentum to bring a lot of product come to Malaysia.
So the current workforce dekat Minibi?
Apa dia?
The current workforce.
The current workforce is about 1,000, include the operator and foreigner. But our engineering team is looking forward to develop the automation because on labor side we have difficulties to get a foreigner also, especially during this pandemic area. So this is where automation is take place. We recruit more young engineers to maintain the production.
Okay, so ada final question? I think boleh close part lah. Okay. Then okay, Ahmad Muhajir memang dah answer I think a lot of questions kali ni. So memang patient lah nak jawab satu-satu. So okay, so I think on behalf of Unimac and Faculty of Electrical Engineering Technology, so saya nak ucapkan terima kasih lah kepada Encik Ahmad Muhajir It's about a very useful sharing, especially for this subject, EDJ29403, pneumatic and hydraulic. So memang all the while, okay, the challenge of this batch, dia ni student COVID, semua belajar online, so lab
Yeah.
pun online, so belajar on the simulation, pernah experience the actual system tu belum sempat lagi. Okay, for this batch. So I think having this kind of talk memang dia bagi banyak pendedahan berkaitan dengan industri. Masa I bagi assignment 12 silinder pun dia orang macam oh very, very big system. Padahal actually boleh go up to 256 kalau one PLC alone. So that's the capacity of the industry lah yang memang kita boleh belajar banyak. So I think memang student pun dapat a lot of info dari experience Encik Mohdi. Okay, so terima kasih banyak. Okay, sebab dapat bagi sedikit sharing. Okay, so maybe in future kita akan buat more talks on this kind of topics.
Okay.
Jumpa Encik Mohdi lagi.
Boleh.
Okay, sebab memang nak dapatkan yang on the field, yang willing to share tu tak ramai. So I think thank you so much sebab willing walaupun cuti raya. Memang kita plan nak buat awal tu sudah bulan puasa.
Sorry saya pun sibuk sikit.
No problem.
Okay.
So I think we managed to settle it today. So I thank the student juga. So, walaupun dia orang next week dah final exam.
Good luck everyone.
So still allocate. Suppose sekarang cuti raya, still willing to join. So walaupun not the full capacity, tapi it's almost 90% of the student are here.
Good.
Okay, so thank you so much once again, Cik Ahmad Muajir, for willingness to be here, and also the student. So thank you. We'll see in the future.
Okay, thank you.
Okay.
So you can take my contact number if you want to ask for in the future on the job. Also can take note my number 017.
Kejap I share dekat chat box.
I share in chat box.
Okay, boleh.
Okay, 017 8907. So there's my number. I'm open. You can ask anything on technical side, or you need to advise on career also, no problem. So yeah, just take the opportunity lah. Yes sir.
Yeah, I think FTKE as a faculty also kami akan approach Milimbi after this. Okay, for the career opportunities. Okay, on the official side lah. So unofficial student boleh contact
Okay.
the number. So officially we will have some interaction juga dengan industri lah. Yeah, especially community. Okay, so thank you so much, Encik Mohdi. So thank you students. So we will meet next in the future. If student, I will meet next week.
Okay. Good luck everyone. Your final exam. Okay, terima kasih.
Okay, thank you.